Okay, kids, let's go ahead and pick up at the very beginning of Module 9.0 Chemistry. It's Exploring Creation with Chemistry, second edition from Bob Jones University Press. Okay, my wonderful foursome of kids. Polyatomic ions and molecular geometry. He spends a lot of time trying to go into this whole idea of polyatomic ions and showing how we have positives and negative charges on an atom according to whether or not it needs to gain or lose an electron, that you also have this same sort of thing going on, and you can have an ion. For example, let's say that we have obviously we know that if we have H2O, that you have one atom of oxygen and you have two atoms of hydrogen. And this would be the structure right there for oxygen, for water, H2O, got a bond there and a bond there with two non-bonding pairs of ions on this oxygen. However, what would happen if you, instead of having two hydrogen, you only had one oxygen? Well, you would have a very smeary board if you tried to keep on erasing it looking like this. So you'd have your bond with your hydrogen. 1, 2, 3, 4, 5, 6, 7. But still, see right here, you're only missing one electron. So since you're missing one electron, and an electron, you're missing one electron, this actually has a -1 charge, because what they're saying is, let's say that a sodium happens to come along. Sodium, if you look in your book, and hopefully I'll remember what I'm doing, should have it has one electron to give away. So when sodium comes along, it's very happy to give its electron right there, and I actually have my Lewis structure written in the reverse of what it would be, but I would have sodium, which has given an electron to the oxygen, so we now have a very happy situation here. You have what they call sodium hydroxide. So instead of just having an oxygen ion, you actually have this OH by itself, where it has a -1 charge. That's what they call a hydroxy ion. OH negative. It has a -1 charge. Because its Lewis structure has this one spot here, it's looking for an electron, so it has a -1 charge to it. Because this ion has more than one atom in it, comes from an oxygen atom, and it has a hydrogen atom, poly is many. Now we could say that this is a diatomic ion, just from, what is that weird thing there? Okay, I guess that's the automatic focus here. We could say it's a diatomic atom because it has a diatomic ion because it has two atoms in it. But we say polyatomic ion because that way it's however many atoms make up this particular ion, it's still going to work. Anyway, not being particularly clear or concise here, But the crux of the first several pages in Module 9 is simply to tell you what a polyatomic ion is. A polyatomic ion is simply an ion that contains more than one atom. More than one atom. You must know what polyatomic ions are. Now, fortunately, this here says, polyatomic ions are ions which are formed when a group of atoms gains or loses electrons. So it's any ion that contains more than one atom. Let me put another thing. This is a description of what it is. This is here his technical definition. What a polyatomic ion is, you'll want to know this. Polyatomic ions, these are formed when a group of atoms gains or loses electrons. Formed when a group of atoms gains or loses an electron. Lose, not lose, gains or loses an electron. Fortunately, there are not a whole bunch of them, but there are a dozen or 15 of them. I think it's actually 14 of them. And you're going to have to know what those ions are. You're going to have to know what their charge is, so that you are able to draw a correct Lewis structure, so that you can come up with the molecular geometry. Polyatomic ions, they are formed when you've got a group of atoms that is either looking for an electron or wants to give an electron away. Polyatomic, many atoms. A polyatomic ion contains atoms, more than one atom. Okay, and I know you can write this down, or you can get it directly out of your book. Now, this is what you are so not going to enjoy, but you've got to do it, and it wouldn't surprise me for Mrs. Harrell to use some of these polyatomic ions as extra credit for you. Table 9.1, right here. This is on the top of whatever page this is. Top of page 288 in your book. He says learn these, period, end of story. Let me go ahead and read them, beginning at the top left. This is ammonium hydroxide. It's NH4, it's +1. Hydroxide is the OH ion that we just did. It has a -1 charge. Chlorate is ClO3, has a negative charge. Chlorite, ClO2, has a negative charge. Nitrate, NO3 negative. Remember we had nitrate, chlorate. There's a connection with the number of oxygens. Nitrite, NO2, it's a negative charge. You have acetate, C2H3O2, has a -1 charge. Cyanide, CN, has a -1. Carbonate, CO3, is a -2. Chromate, CrO4, is a -2. Dichromate, Cr2O7. You think, oh, that's just a multiple of it. Well, it's not, is it? There are twice as many chromiums as in chromate, but there are not twice as many oxygens as there are in chromate. So dichromate, Cr2O7, has a -2 charge. Sulfate, SO4, is -2. Sulfite, SO3, is -2. And phosphate, PO4, has a -3 charge. Now, do whatever works best for you. Write them out a bunch of times. put them in some form of alphabetical order, or make some sort of a nonsense sentence, but you need to be able to know if it's, because you're going to have a formula that's, well, here, what is the chemical formula of magnesium phosphate? This is what we're going to work on in just a minute, but you'll have a test question or a homework problem that says, create this. The homework problems, you can go back and look in your book. Your test questions, you have to do without the book. So take the half an hour or however long it's going to take you to memorize these, spread it out over a period of days. Maybe every time you sit down this week, write out NH4 plus, OH negative, ClO3 negative. Write them all out so that you are able to know what those charges are. Now, did you notice that there's only one of these, and it's the ammonium? It's the ammonium ion. That's the only one that has a positive charge. Now remember, we've talked a lot about ammonium hydroxide, haven't we? Well, ammonium, NH4, has a positive charge. Hydroxide, OH, has a negative. Positive and negative attract each other. NH4, OH. And now you see why sometimes they're going to put things in parentheses, because this tells you that you have two ammonium ions. It's not that you have two nitrogen two nitrogen atoms and 4 hydrogen atoms. It's that you have this ion thing all hooked up. Because let's see, why is that an ion? Let's look back here at nitrogen. Nitrogen has 5 electrons. That can't be right. Nitrogen, what did I do wrong? Nitrogen and 4 hydrogen. Nitrogen has 5, 3, 4, 5. Hydrogen is 4, 1, 2, 3. It's got this extra one out here that it wants to give away, because it really has 9 electrons out here in its outer energy area. It takes this one. Remember that hydroxide? You have OH. You've got this shared bond here, this connecting bond here. From the hydroxide, from the ammonium ion, you have this one extra electron. It slips right into here into the hydroxide ion. That's how you end up with sodium hydroxide. So anyway, there are those 14 ions that you need to learn. The vast majority of them, 13 of the 14, have a negative charge. You have to know what the negative charge is, period, or else you're not going to be able to write the formula. What is the chemical formula, example 9.1, for calcium nitrate? Okay, so calcium, did it say nitrate or nitrite? Nitrate. Calcium nitrate. And that's actually a small c. How are we going to know what to do to create this chemical formula? Remember what they said to do. Check and see the number of electrons that are in its outer shell. So you look at calcium and you see that calcium has 2. So it has a charge of positive 2. Nitrate, you look at your little chart until you learn that nitrate is NO3 with a negative 1 charge. NO3 with a charge of negative 1. If the signs are opposite, you switch the numbers. So we have 1 calcium, and we have 2 nitrate ions. This right here is going to be your chemical formula. Now let's look and see. CaNO3, 2 of those ions. And this right here is exactly the example that I was talking about before as to why you have some of these chemical symbols in parentheses. It's because it's not that we need 2 of the nitrogen or 2 of these ozone molecules here, but we need 2 of the nitrate ions. Okay, this is how you do calcium nitrate. Now, what do we want to do for the next one? What's the chemical formula of magnesium phosphate? So this is 1. Here's 2. And we have magnesium phosphate. Well, it's magnesium and phosphate. Phosphate, you know, is not an element. Phosphate is an ion. Look over here on your chart. PO4 has a -3 charge. PO4. So the phosphate ion has a -3 charge. What about magnesium? Look at your chart, your periodic table of the elements, and you find magnesium, which is in column 2A. That means it has 2 electrons that it's trying to get rid of. Okay? Using the shortcut method that J. Weil taught you in chapter 7, you just drop the signs and you switch places. So we have 3 magnesium, PO4, 2 phosphate ions. So let's see, that's what we have. Mg3, PO4, in parentheses, 2. So, that's how you do the magnesium phosphate ion. Now, this is still example number 1. What is the chemical formula for copper acetate? Let me use this different color here. We want to do copper acetate. Copper 1 acetate. Now, the name for this just flew right out of my mind, but this right here, what is it that they're called? Isotopes. When you have when an atom can exist in nature in more than one state, they have isotopes. This is copper 1. This tells you what its charge is. This has a positive charge. What does the acetate ion have? Acetate is C2H3O2. So you have copper, which is Cu, acetate, C2H3O2, C2H3O2 has a negative charge. This is copper 1, it has a positive charge, +1 charge. This has an electron giveaway. This needs an electron. This is the same. So copper acetate is simply Cu C2H3O2. So that's how we're going to work on these 2 together. We want to now balance the following chemical equations. I'm not going to go ahead and do those because we have question on your own at 9.1 and 9.2, and we want to be able to go over those in class tomorrow. I'm going to call this the end of part 2 video.